everyone, this is Algebra 1, Lesson 2, and this lesson covers angles, polygons, triangles, and quadrilaterals. So most of this should be review of a bunch of geometry concepts. Alright, so the first one is intersecting lines. So these are just a bunch of terms that you guys need to know. Intersecting lines are going to be lines that cross. So these two lines here are crossing, and there's our point of intersection. Okay. So intersecting lines cross each other somewhere. Parallel lines don't cross. So that would be like here and another line running next to it that doesn't cross it. Like train tracks. Perpendicular lines, these are going to cross at right angles. And what that means is that it makes a square corner. So these lines are perpendicular. They have square corners. A straight line, or a straight angle. Okay, so angles. Angles are where the lines cross and we get this area right here between. It's the measure from one line to the other line. Okay, and this is measured in degrees. A straight angle would be an angle on a straight line. So like from here to here. That would be a straight angle. And it's going to be 180 degrees. So straight angle is 180. An acute angle is anything less than a 90-degree angle. So remember, a 90-degree angle is right here when it makes a square corner. Okay, and two 90-degree angles make 180. So if we went all the way from here to here, that would be our 180, which is straight. So anything less than 90, like this one right here, is called an acute angle. So that's going to be less than 90. So we can remember that as it's a cute little tiny one. An obtuse angle is going to be anything more than 90. So this big one is more than 90, because 90 would be about right there. I can't draw a straight line, but it'd be like if there was one going straight up from here. That would be 90. So this is more than 90, so that's obtuse. Okay, so really easy. A right angle makes a square corner. That is 90 degrees. A straight angle is two 90-degree angles together, and it makes a straight line. An acute angle is less than 90. And an obtuse angle is more than 90. Okay. All right, next slide. All right, polygons. A polygon is a special kind of geometric figure whose the word polygon is formed from the Greek word poly, which means more than one or many, and gonon, which means angle, so many angles. So it's a unique geometric figure with many angles. It could have any number of angles. So a polygon is closed, flat geometric figure. Closed, flat geometric figure. Okay, so what does it mean by closed? Well, if we have sides, and it doesn't matter how many of them, as long as they're straight lines. Let's get rid of that. That wasn't very straight. So like a square, right? That would be a polygon because it's closed. Things that wouldn't be polygons, so if we had that, see how it's not closed? If we added an extra line, then we could make it closed. That would not be a polygon. So this one is not a polygon. Okay. If it has a rounded side, so the sides have to be straight lines. If we've got a rounded side, then it's not a polygon. So that one's not a polygon because its side's rounded. It has to be straight lines and it has to be closed. All right. The figures in A and B, blah, blah, blah. Okay, I already read that. Let's see. Okay, so different types of polygons. The polygon with the least amount of sides is going to be a triangle, and we already know what a triangle looks like. And that one has 3 sides, so polygons are named for their number of sides. A quadrilateral has 4 sides, so a triangle is going to be like that. A quadrilateral would be anything like that. A pentagon has 5. So that would be a pentagon. Mine are a little wiggly. Imagine those are straight. A hexagon is 6 sides. Kind of like that. An octagon is 8. So that's like a stop sign. Alright. I can't draw all those because it's hard to draw with this pen tool. Alright. A concave polygon. Concave means it has a cave. And I'll show you what that means. So if you have a figure that looks like this, but then it jags in like that, there's the cave. Okay, so there's a cave in it. That means it's concave. Convex means it doesn't have a cave. Okay, so that would just be a regular figure with no cave in. So that one would be concave because it has a cave. This one is convex. It could just be a regular square would be convex. Anything without a cave going in. Okay. Next set of terms. Equilateral polygon. All right, so an equilateral, lat means side, and equa means equal. So this is going to mean that your sides are all equal. So lat means side, and equa means equal. So the sides are of equal measure, equal lengths. Equiangular, equa again means equal, but angular means angle. So these are going to have angles of equal measure. A regular polygon is going to have, these are going to be the ones that the shapes that we learned when we were kids. These ones have the polygons in which all sides have the same length and all angles have the same measure are regular polygons. So equal angles and sides. Okay. All right. Let's see. So then we have some names for, let's see, this one would be equiangular. So all these angles are the same right here. This is all 4 right angles, but it doesn't have sides that are all the same. On this one, let's say that these sides all measure the same and the angles all measure the same. We would call that one a regular polygon. All right, so the sum of all the angles in a triangle always equal 180 degrees. So we're going to be talking about triangles now. So that means that if we add up all 3 sides, the measures of all 3 sides, 1, 2, and 3, it has to equal 180. Okay, a right triangle is a triangle who has a right angle in it. So I can move this triangle around here and make it have a right angle. Put that there, that one there, and then put this one down here. And we've got a right triangle. That means that this angle, at least one of the angles in there, is square. All right, that one looks like these two would be even. Okay, those two would be even. And that is called an isosceles triangle. or any triangle where you have two sides that are even. So these two sides are the same length. So that's an isosceles triangle. All right. Now, if we have an acute triangle is going to be triangles where one of the angles, let's see, if all the angles have a measure less than 90, then it's an acute triangle. So let's see if I can shrink this guy down and make it be an acute triangle. If I just take that and move it to there, then we're going to have an acute triangle because all of those angles measure less than 90. All angles less than 90 degrees. An obtuse triangle has one angle that's greater than 90. Okay, so let me see if I can make that into an obtuse triangle. Alright, so if we make this angle over here really big, then it is more than 90. Right there. So there's our obtuse angle, which makes this into an obtuse triangle. Equilateral triangle, remember, equal means equal. Oh, this is equal angular, and angular means angle, so that is equal angles. So all the sides are equal and all the angles are equal. That is a special kind of triangle. An equilateral or equal angular triangle. Let's see if I can make one here. Let's see. And then I would have to move that until all of these were the same. And how they mark whether or not they're the same, they'll just put a mark through here. And that tells us that all three sides are the same. Or they'll do that with a little mark through to show you that all three angles are the same. So an equiangular triangle has equal sides. An equilateral, or equal angles, because of angular, an equilateral triangle is going to be equal sides. So remember, whenever you hear lat, think of sides, and angular is angles. All right, a scalene triangle has no sides that are equal, and therefore that means it will have no angles that are equal either. So let's see if I can turn this into one of those. Okay, so this one, each side is different. So there's this side, and it's different from that side, and it's different from that side. So all three angles and sides are different. Okay, all sides are different. The lengths of the sides of a triangle and the measure of the angles opposite these sides are related. In any triangle, the angles opposite the sides of equal lengths have equal measure. Also, the other way around, the sides opposite the angles of equal measure have equal length. So what that means is that this angle relates to its opposite side, which will be here, okay? And then this angle is going to relate to its opposite side, which would be that one. And then this other angle is going to relate to its opposite side, which would be that one, okay? That means that if we have two angles that are equal, that means that the sides will be equal as well. So let's say we take this triangle right here and we have this angle and this angle are equal. That means that the opposite sides, here, that's the opposite of that one, and here will also be equal. Okay? Now let's say that this third side was not equal. That means that the one opposite it will not be equal to those two. Alright, so an example, they ask us to find x. So on this one, we know that all of the angles have to equal 180. So all we have to do is add these two together and then subtract that from 180. So if I got 130 plus another 30, that would be 60, 160. And then I take that away from 180, and I get 20. So the answer to that would be x equals 20 degrees. Because they have to equal 180. Super duper easy on those. Find x and y. Alright, so on this one, I've made my diagram wrong. Let me fix that real quick. Delete that bottom line. Well, if it'll let me. Delete. Can I move it? Nope. Aha. There we go. Okay, it's supposed to look like that. Okay, that's what it's supposed to look like. Alright, so we've got x and y, and we've got 50 degrees. So, these lines through right here, this one shows us that it's related to that angle, and then this one is related to that angle. And these two lines right here mean that these two sides have the same measure. So this side is equal to this side. That means this angle has to be equal to this angle. So x has to equal 50. Now, we know that they have to equal 180 together. So if we have 50 and 50, that would be 100. And 180 is what we have to have. So if we subtract, we figure out that y equals 80. So 80 plus 50 plus 50. 50 and 50 is 100, plus 80 more is 180. All right, another example. This is 2.3. Find x and y on this one. Okay, this is basically the same as the last one. We have two sides that are the same. So this side is the same as this side. That means that its opposite angle would be over here where x is, right? And the opposite angle of this one right here would be over here where y is. That means x and y have to be equal. Okay? But we don't know x or y. So what we have to do is try to figure that out. All right, so we know that 150 right there. So we start with 180 and we subtract our 150, and that'll tell us what we have to have left. So that would be 180 minus 150 would be 30. No, it would be, yeah, that'd be 30. And then we have to cut that in half, because 30 is for this angle and this angle, and they have to be even. So if we made this one 15 and this one 15, then we got 15 and 15 is 30. 30 and 150 is 180. So x equals 15 and y equals 15. I think in the example in your book, the numbers were a little different. All right, some different types of quadrilaterals. So remember, a quadrilateral is 4 sides. So these are going to be shapes with 4 sides. And these are different types of them. All right, so a parallelogram has 2 pairs of parallel sides. So here's the side, and here's the side. And to show that these are parallel, they'll do little arrows on them. And then maybe we have, whoops, that's not very good at all, a side right there, okay, and a side right there. And these are parallel to each other. So 2 pairs of parallel sides. Not all 4 parallel to each other, but just 2 and 2. 2 pairs of parallel sides. I probably spelled that wrong. I'm terrible at spelling. All right, a trapezoid. A trapezoid is a quadrilateral that has exactly 2 parallel sides, so only 1 pair. So that would look something like we've got this line and this line that are parallel, right? But then this one goes like this, and maybe this one goes like this, and those are not parallel on the ends. That'll be a trapezoid. All right, a rectangle. A rectangle is a parallelogram with 4 right angles. And we all know what a rectangle looks like. The main thing is that those angles are right. Oh, that was terrible. Erase that. Let's see if I can make one like this. Okay, right angle, and right angle. All right, so the main thing is that it has square corners, so it has to have 4 pairs, 4 right angles. A rhombus is an equilateral parallelogram. So a rhombus can look like, let's see, get rid of that arrow. Like that, as long as all the sides are equal. So this one and this one and this one and this one are all equal. So 4 equal sides. But the angles aren't equal. These are skinny, those are fat. Like this one's an acute angle, whereas that one is an obtuse angle. Okay, the angles aren't the same. A square is a rhombus with 4 right angles. So it's going to have 4 equal sides and 4 right angles. Okay, so let me turn that into a square instead of a rhombus. We can go up there. There we go. Nope. The sides have to be equal. Let's see. And we know what a square looks like, don't we? We learned that in kindergarten. There we go. There is a square. And what makes that a square is that our sides are equal and our angles are all 90 degrees. So square corner, 90 degrees, and all of our sides are equal length. Okay, that's what a square is. All right. So go ahead and pause the video and work the practice problems, and then I'll work them for you. All right, so hopefully you pause the video and work these practice problems, and now I'm going to work them for you. All right, so this one we have to find x, and we already have 2 of our angles marked, so 55 and 55. If we add those together, we're going to get 5 and 5 is 10, carry the 1, 10, 11, 110 degrees. Now we know that all the angles added together has to equal 180, so we're just going to do 180 minus 110, and that would be 70. So x should equal 70 degrees. All right. Next one, this is B. Okay, so for this one we have to find x and y. Now this mark right here shows us that this angle is the same as this angle. Okay, so that one's opposite to 40 and this one's opposite x. So 40 and x have to equal each other. So that means x equals 40. Right, so if that's 40, we have to figure out what y is. Well, if we add 40 and 40, we get 80, and then we just do 180 minus 80, and we're going to get 100. So y equals 100. Okay, next one is C. All right, so this one, we have to find x and y. This 10 right here tells us that that's related to this angle. And if this one's 10, that means those two sides are equal, which is related to this opposite angle. So that means x and y are equal to each other. Okay? But we still don't know how much either one of those is. So we're going to have to take our 112 and subtract that from 180. And we're going to get 68. But that means that x and y both have to share that 68. We have to split that in half. So we're going to do 68 divided by 2. And that would be 34. So both of these are 34 degrees. So x equals 34 and y would equal 34. And to double check that, we can add them all back together and make sure we get 180. So 4 and 4 is 8, 9, 10, carry the 1, 3 and 3 is 6, 7, 8, and 180. Okay, so always add them back together and make sure you come up with 180. All right, that is it for lesson 2. Thanks for watching.